Okay, this is going to be the Algebra 1 quarter test for 2014, 2015. You should have a review packet. Most likely be taking this test online, but I'm going to go through the review packet. Okay, so the first problem here, okay, all right, graph the following, all right. What you need to do is graph the anchor point. We're at -2, -3, so -2, 1, 2, and 3, okay. All right, normally the points for the quadratic are, let me actually move this over a little bit. I'll do it right here actually, okay. Quadratic are 1, 2, -1, -2. All right, so the quadratic x and y, which we're using as x squared, okay. All right, that's going to be 1, 4, 1, 4. Now, since I have that negative out front, I'm going to multiply everything by -1. Okay, so it's -1, -4, -1, -4. Okay, so that means right 1, down 1, right 1, down 1. Okay, right 2, 1, 2, down 1, 2, 3, and 4. Left 1, down 1, left 2, down 4. And it's going to be like a U shape. Okay, all right, my absolute value here. All right, what I'm going to do is I'm going to graph the left side of it first. Okay, all right, menu. All right, so I'm going to go to graph. I'm going to graph the left side first. So I'm going to do. I'm going to put the exact inequality in. So type, then over, then 4. All right, negative option, num. All right, ABS. Oops, too many ABSs. All right, x minus 1. All right, plus 4. Okay, now that one's going that way, so when I do the next one, I flip it around and I go that way. All right, 2x plus 1. All right, draw. All right, I'm going to F3. I'm going to get myself a little bit. All right, so that's what I got there. So from a standpoint of an answer, G-solve intersect, I got 1.3, so it's going to be x is less than 1.3. Okay. Repeating, okay? Now, as far as graphing it goes, all right, what I'm going to do is I'm going to graph that intersection, 1.3 comma 3.6, 1.3 comma 3.6, so about right in here, okay? Somewhere in there, all right? I'm also going to graph my anchor point, which would be 1, 4, 1 right, 4 up, okay? So I'm going like this, okay? All right? And then if you want to get the anchor point, G-solve max in this case, I want to find the maximum of that. That would also tell me. Now I want to find the G-solve, the y-intercept of not the absolute value, but of my line, which would be 1. All right. So, all right, I can just go ahead and draw this. All right, and then I just copy the shading. Okay, so it's shaded like all in here. Okay. All right, moving on. Okay. All right, now this one, all right, what I'm going to do on this one, okay, I can figure out the shading first if I want, all right, and I'm going to delete these two things. Now, as you can see here, all right, this is a y equals 1, so I only got to graph the right side. So the type, all right, okay, 3, option, num, ABS, x plus 2, all right, minus 1. All right, draw. That's what I got. So I'm going to try to emulate that. So my anchor point here is 2, -1, or -2, -1. So it's going to be about right there. For absolute value, so we're using absolute value there. All right. So that's 1, 2, -1, -2, 1, 2, 1, 2. Makes those positive. Got 3 out in front. So I got 3, 6, 3, 6. So 1 right, 1, 2, 3 up. 2 right, 1, 2, 3, 4, 5, and 6. 1 left, 3 up, 2 left, 6 up. Okay, now since that's got that there, that's going to be a dashed line. Okay? All right, and then just copy the shade. Shading says that, so all I got to do is shade on the outside. Okay? Next. Okay, apply all the following. Okay? All right, what you should do for this is look at the anchor point. My anchor point is 1, 2, 3, 1, 2, 3, 4. So I'm -3, 4. So what happened? I shifted left 3, I shifted up 4. Okay, all right, I reflect over the x-axis. okay? Reflect over the x-axis now, all right? The way that would work, this would not be a dilation, because normally with quadratic, I'm 1, 1, 2, 2. I'm still, I'm 1 right, 1 down, okay? That would be a dilation of -1, which is not a choice there, okay? All right. Okay, so number 1 here, what is the solution for that? All right, what you should be able to do with that, okay? All right, if you have your calculator, make sure you've deleted all those, okay? Now, if you need to turn it back to equals, do type y equals, and that turns it back, okay? So I got -2x. Always graph the right side first, then option num, ABS, x minus 3, draw, all right? G solve intersect. So my answer is x equals -3, okay? That's all for that, okay? Which set of values makes up this equation, okay? Once again, I'm going to graph the right side, so it's going to be 8. I'm going to graph the left side, 3. Oops, let me delete that. Option num, ABS. I want that part of 3x plus 4 to stay inside. All right, draw. All right. G solve intersect. One of my intersections is -4, 8, and the other one is 1.38. So I got -4, 8, and 1.3, 8. Now, all I want out of that is the x coordinate. Okay, and that's my answer for that. All right. I'm going to stay with. Actually, I'll keep going with this. Okay. So number 3. All right. Once again, now I'm going to go back and delete a few things. Now, what you should be able to do is you should be able to graph this both the inequalities and the number line. So what I'm going to do is type, all right, I'm going to use this exact one that I see, and I'm doing 8. All right, always graph the right side first. I'm going to flip that around, okay? I'm doing option num ABS, all right, x minus 8 plus 4, draw. All right, I'm going to move this over. You can move it over so you can see it. Make sure you can see both intersections. So G solve intersect. One of them is 4. The other one is 12. Okay, so when I make my number line, if you notice, that matches up. See, it's even telling me 12 is that one, 4 is that one. All right. Also, if you look at the circle, all right, if you look at the shading is in between. So what I'm going to have, open circles, shading between, that's the inequality of x is greater than 4 because it's going to the right. This one is going x is less than 12 because it's going to the left. All right, so you should be able to do both. All right. All right, 4, write an absolute value inequality. Okay, so what you should do first here is figure out this distance. So imagine you're a person and you're hopping from one to the other. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so 12 spaces. I want to cut that number in half, so it's 6. Okay, it's 6 spaces. All right, now what I want to do is hop back and use another marker. I want to hop back 6 spaces. So 1, 2, 3, 4, 5, and 6. So I ended up right there. Now what that tells me is absolute value. I use the opposite, so I actually use -2. Since this is a closed circle, I'd have a line underneath it for the inequality. I only have to look at this one. If it's going to the left, it's going to be less than or equal to. Now, let's say you wanted to check that. What you can always do, all right, is let's say I want to delete this, I want to delete this. I said, okay, is that the right inequality? Type F4, 6. Switch that around. Type, all right, F3, all right, option num, ABS, x minus 2. So, if I draw this, the shading's in the middle. That matches up what I have here. So I'm good on the inequality. Now, if the numbers are right, if I do G solve intersect, -4 is that one, that's where it is there, and 8 is that one. So I'm good to go. Okay? All right, let's take a look at this one. Delete, delete. Okay, so type greater than or equal to 10. I'm doing the other side, I'm flipping that around. So type, all right. I'm choosing the other one, which is F4, okay, -2, option num, ABS, all right, x plus 3. All right, draw. Okay? Now, as you can see, G-solve intersection, I got no shading and no intersection. So this is going to be no solution. Okay? All right, that's the answer for this problem right here. Okay? No shading, no intersection. All right? If you have no intersection, but you have, let me put intersection. Okay, enter. All right, intersection, and you have shading. Just to let you know, if you see this, that's going to be all reals. Okay, just to let you know. All right, graph the inverse function. Okay, here's how you do that. Look at these points. That point right there is 1, 3. This point right here is 2, 4. This point right here is 3, 1, 2, 3, 4, 5, 6, 7. 3, 7. So what you should do is either, if they don't give you the points, find spots where it meets grid spots. To find the inverse, all you do is flip x and y. So 3, 1, 4, 2, 7, 3. Okay? So 3, 1, 3, 1. Okay? All right, 4, 2, 1, 2, 3, 4, 1, 2. Okay? And then 7, 3. 1, 2, 3, 4, 5, 6, 7, 1, 2, and 3. Okay? Now, the anchor point of this one is going to still be the anchor point, so it's going to go through that. Okay? All right, so go through that. So keep the same anchor point. All right, if f of x equals that, what's the inverse? Okay? Now, a couple ways you can do this. You can either do it the short way or the long way. Okay? The shortcut way is, well, let me do the long way first. All right? So f of x is a fancy symbol for y. Okay? I switch x and y. I want to get y by itself, so the 2 is going to move over. It's become minus 2. I'm going to move the 3 over next, okay? And it's multiplied, so it's going to be division when it moves over. Okay? To get rid of that squared, I square that like that. Okay? And that's your inverse right there, okay? Now, the fast way to do that is if it's plus 2 on the outside, it's going to become minus 2 on the inside. The opposite of the square root is the squared, okay? Instead of multiplying that by 3, we're dividing everything by 3. So that's a fast way to do that. Describe domain or range inverses of inverse functions. Okay, so like if a domain is like x is greater than or equal to 3, and the range is y is greater than or equal to 4, then when you do the inverse, okay, it's going to be, the domain is going to be x is greater than or equal to 4, and the range is going to be y is greater than or equal to 3. The letters are still x and y, but the numbers switch, okay? All right, number 9. Find f of g of negative 4. So what that's telling me is to start with that f function, put a space. The next letter tells me put the g function in there. Now, since they want me to do negative 4, I can use the calculator for that and figure out that answer. So menu, run, all right, negative 4, arrow for x. All right, and then I'm going to type this in just like I see it. X minus 1 squared plus 2. Okay, and that answer is 27. All right. G of f of x, so I'm leading with the g function. I remove everything where x is and leave a space. The next letter is what I fill in. Now, squared means right twice. Okay, so when I do that, I have to do the boxes. 4x squared, 6x, 6x, 9. Okay, 3 times 2x is that, 2x times that is that. Okay, now when I combine all my like terms, don't forget about the negative 2. So I got 4x squared plus 12x. It's not going to be 9. 9 minus 2 would be 7. Okay, all right. F of g of x. What could f be? What could g be? Now it's sort of like working backwards. The question you have to ask yourself is what went into parentheses? Okay, what went into parentheses was x plus 3. What's your f of x? Okay, all right, you got x squared minus 4. And the way you can check that is, okay, well, wouldn't I do this if I was doing the composition and fill that in? Okay, that's how you do it. So the question, to get the g, it's what's in parentheses, okay? All right, then imagine that you just cross that out and put where x is. That tells you what that stuff is, okay? All right, I think we're up here for 12. Okay, what is the domain of the following? All right, so I label that point. That's negative 2, 1, 2, 3, 4. Oh wait, 1, 2, 3, 4. So that's negative 2, negative 4. This would be infinity, infinity. So to find the domain, the smallest x value is negative 2. The biggest x value is infinity. I care about the number part, which is it's eating the x. So which one's eating the x with the line underneath it? Boom, that's D. Okay? The range. Okay? What's the range? All right, so once again, I'm going to lay, what's that anchor point? 1, 2, 3. 1, 2, 3, 4, 5, 6. So that's 3, 6. This would be negative infinity, negative infinity. This would be positive infinity, negative infinity. All right, right arrows are always positive infinity. Left arrows are negative infinity. They're both going down. So the smallest y value I see there is negative infinity. I'm sorry, yeah, the smallest y value I see is negative infinity. Okay, all right. The biggest y value I see, whoops, I shouldn't put a line underneath that. All right, the biggest y value I see is 6 with a line underneath it. So my range, okay, to answer that question, all right, is y such that y is greater than or not greater than or equal to, less than or equal to 6, okay? That's the range, okay? Because that's all I care about. If you notice, it's the same thing. What's the y-intercept of the graph above? That's right here. That's 0, negative 2, okay? What's the x-intercepts of the following graph? All right, that's here and here. That's what x-intercepts are. So that's 0, 0, and 1, 2, 3, 4, 0. Okay, so it's where it crosses that axis. Are we moving on to 15? Okay, what are the zeros of this function? None. Okay, doesn't cross the x-axis, so that's how you know there. Okay, over what intervals is this increasing or decreasing? Well, let's label some things. Negative infinity, negative infinity. All right, that is, okay, so the graph here, a little confusing on the graph. So this is like the origin. This is 0, 0 right here. So that's negative 2, 0. Okay, that's like, let's say 1, now negative 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's just call that 210, 2 negative 10 for starters now. All right, and then that's going to be infinity, infinity. Now, what we care about with these increasing, decreasing, x only. That's all we care about. So, when I write this, I start from the far left, work our way. So that's negative infinity to negative 2. That's an increase. Okay. 2 to negative 2 to 2 is a decrease. And from 2 to infinity is an increase. Okay. All right. So far left, rising, falling, rising. Okay. I think that's it for that one. Okay. All right, draw an example of each type of function. A linear function would be like a line. An absolute value function would be a v. Okay. A square root function would be like a dot with a little ray like that. And what is the other one? A quadratic, I think. Okay. A quadratic function is okay. It's got to be like a U shape. Okay. All right. I don't think we're going to get picky on that. All right, go into the next part. What describes that translation? Well, that's negative 5, negative 4. Remember, we do opposite for inside. So that would be left 5, down 4. So which one's left 5? Left 5 is these two. All right, so left 5, down 4. So that would be that. Okay. Rewrite this in log form. Okay. So what's going to happen is the log is going to have the same base. So there's like 3 parts. That part, and that part. Well, the rule is set the base, okay? Set your base. The exponential equaled 64 before. It can't equal it anymore, so it has to equal 2. 64's got to go there. So there's only 3 parts. First part, set your base. That means you have 2 left. Can't equal the same thing, so the sort of logic takes over there. Rewrite this in exponential form. Once again, set the base. It equaled 2 before. Can't equal that anymore. It's got to equal 25. The 2's got to go for the exponent. Okay? I'm going to show you a fast way and a short way. That's got to convert to a log. All right? So the base of the log, okay, is going to be 7. It was plus 5 before. It's going to move inside the function as minus 5. Okay? If you need clarification on that, the long way is to do it like this with y. All right? There's 4 parts here, so I got to move that 5 over. Okay, now convert it to the log. Log of 7 can't equal x minus 5 anymore, so it's got to equal y. The x minus 5 goes there. So long way, short way, either way is fine. Okay, describe the transformation of this graph. Find the inverse of the equation. Okay, now if a log does not have a base, create a base of 10. Okay, all right. So the transformation is 2 left, 1 down. Okay. Now when you go to, let's do the shortcut way. All right, it's going to be an exponential with a base of 10. Instead of minus 1 on the outside of the function, it's going to become plus 1 on the inside. Instead of plus 2 on the inside, it's going to become minus 2 on the outside. Okay, once again, if you want to see the long way behind that, all right, that's going to be x equals log of 10, y plus 2 minus 1. I've got 4 parts here, so the minus 1's got to come over. Okay, now when I go to convert it, this can no longer, the base is 10, can no longer equal x plus 1, got to equal y plus 2. The x plus 1 is going up there, and then the 2 would move over, and that's how you get y equals 10, x plus 1, all right, minus 2, okay? All right, let's see here. Write the equation the following. Okay, so that anchor point is 1, 2, 2, negative 2, 2, okay? So with the absolute value, all right, y equals x plus 2 plus 2. All right, opposite on the inside, follow on the outside. Now, what you have to look at is what are the normal points? 1, 1, 2, 2. Now you probably only need that much. What happens? I go 1 right, now I actually have to go 1, 2, 3 down, okay? If I go 2 right, I go 1, 2, that's 1, 2, 3, 4, 5, 6 down. Now, how do you go from that number to that number? A multiplication of negative 3, so that's why that's that. Okay? All right. I can't really tell much from that. That grid didn't show up for me, so see your teacher for that one. All right. This one's going to be 1, 2, 3, 1, 2, 3, 4, 5, 6. So that's 3, 6. Okay? All right. So that's a quadratic. All right. Opposite on the inside, follow on the outside. Normal points for quadratic are 1, 1, 2, 4. But what happens here is I go 1 right, 1 down, 2 right, 4 down. The only way that can happen is a multiplier of negative 1. Just to let you know on this one, the points you should be using for square root are 1, 1, 4, 2. So see how that goes. I'm unsure what that graph is really. Okay? All right? And I think that's it. Okay? If you go through that sample test, you will do very well on the quarter test.